Hi everyone. Today we're going to look at multiple representations. And what this means is like if we could write it as an equation, a table, a graph, we can show it in multiple different ways. They might give it to you as like a word problem and you have to do the rest, or they could give it to you as a table and then you have to work from there, or again as a graph. Okay. Um, they might give you an equation and say what scenario matches this equation as well. So let's look at the first one. Let me change my pen color. Let's see, y'all can read red. So on this one, they give us a description. So like a slight, prompt scenario, and we need to write the equation. So it says that the baby giraffe measures 6 feet tall when it is born. So that is like the starting point. All right, that would be our y-intercept. It's already 6 feet tall. So I'm going to write that at the end of my equation. And so now I just need to figure out the slope, because remember what we learned, we have our slope and our y-intercept. So it says, and, that's a good keyword for plus, and it grows an average of 1.5 foot each month. Keyword each. We're going to just go ahead and keep it as 1.5. And you remember that whenever we work with it, though, feel free to use 0.5. It's easier to put in your calculator. Some of y'all are much happier with a decimal than a fraction. Okay, so let's look at the next screen. Now we're going to put it in a table and a graph. So I'm going to write it each way again for you. 1/2 x plus 6, or you could use the decimal version of 0.5x. Oh, my 5 ran into my decimal. Make that a little bigger. Plus 6. So either one of these will work. Okay. I'm going to say in a table, it's definitely going to make it a little bit easier. So you have a yellow calculator. If you're at school or at home, you have a Desmos, which is a graphing calculator. So you can use either one if you are at school. Let me pull up the graphing one. Okay. So this is what's great about Desmos or your yellow calculator. If you in your yellow calculator, you go to y equals. It's the top left gray button, and you can type in your equation. In Desmos, you can type it in as well. Y equals, and we had 0.5x plus 6. And look at that. You might have to scoot your graph a little bit, but it should show you a line, which is what it would be graphed. So now what I'm going to do is go back and we're going to look at that table of values. Okay. So it talks about process and then how much is your height. So if I plugged in a 0, this is what your Desmos did or your calculator did. If I plugged in a 0 at 0.5, I plugged in a 0 for the x, because remember the months is your x and your height is your y-axis. And you had 0.5x plus 6 is what we're plugging into. All right, so 0.5 times 0 plus 6 is still going to give us 6. It showed us that there, right there. Now, if we wanted to look at what 1 was, if you hold on to it, you can figure out that 1 is 6.5, 2 is 7, right there, okay, and so on. Now, so again, I'm going to put in 0.5 times 1 in my calculator plus 6, and it will give me, we already know, 6.5. It's going to go up by 0.5 every time. That is our pattern, because remember it said it was growing 1/2 every single month. So you can take time and fill this out, please. It's a good reminder of what you're actually doing and what that graph means. And you can put 0.5 times 2 plus 6 and continue on, so forth and so forth, all the way down. Okay? Now, over here on your graph, we actually are going to fill in. So this is our y, is our height, and I'm going to try and write it sideways. But my sideways writing, I don't know if I've ever written try to sideways. It's looking pretty good. Anyway, y'all can turn your paper. I can't. Your months are down on the x-axis. So be sure if your graph is not labeled, you label it. I'm going to go by ones on my x-axis, so fill that in as well. That way you know what you're doing and I know what you're doing. If I saw your paper, you would have a correctly labeled graph. And here's the deal. On the y-axis, if I went by ones, you would barely see a change and it would be way up here, okay? Because it starts at the 6, right? Now, if I go ahead and go by 2s or by 3s, I might be able to see my graph a little better. So let me go by 2s. All right, 2, 4, 6, 8, 10, 12, and I'm going to go ahead and stop. Alrighty, so at 1, or at 0, it was at 6, so I'm going to put a dot here. At 1, it was 6.5, so maybe right there. At 2, it was directly in the middle. At 3, again, it was 7.5, so almost there. 4 was 8. Let's go down to an easier one. 6 is going to be at 9. So that means this one's kind of in the middle. All right, so it gradually grew. So I'm going to try and connect my points with a line that goes through the dots. Again, kind of hard with my cursor here. Your line should definitely be straighter than my line. All right, so that's showing that scenario with an equation, with a table, and a graph. Multiple different ways. It says here, explain how you found your ordered pairs to create your graphs. Well, we plugged in, didn't we? Okay, so we can write that down. Plugged in values. What is the slope of the graph? So we said that our slope of our graph was 1/2, and that is how much it grows every month. And your y-intercept, if we go back and look, it was 6. And that means, you remember, he said he was 6 feet tall when he was born. What does the ordered pair 9-10.5 represent in this situation? Okay, so it's saying if we kept our table going and we had 9 and we know it's 10.5, so what would that mean? It means at 9 months, the giraffe was 10.5 feet tall. Same thing here. If it was 12 feet tall, how many months old is it? So it's saying it's 12 feet equals 1/2 x plus 6. Remember, we can take away that 1/2 and we can put 0.5 if we wanted to put 0.5. Okay, so I'm going to minus the 6. And now we're left with 6 equals 0.5x. And if I divide by 0.5, our months should be 12 months. I'm going to write it over here on the left side because I have no room. Alrighty. Next problem. Now, on this one, they give us an equation, and we're going to have to maybe write up our own description and do a graph and then do our table, okay? So the cool thing is they already told us basically what it's about. So it says that we're going to have pizza cost and toppings, all right, and the number of toppings that we have. So the first thing I'm going to look at is my equation and notice that the x has to be the number of toppings. All right, so I'm going to put a little X right here. That is your topping, so that means your cost of your pizza is your Y. All right, so this is how much probably for each and every topping you're going to buy. And then 12, even if you get 0 toppings, you still have to pay for your pizza. So you're going to pay $12 for a pizza that has 0 toppings. That is what that means. If I were to plug it in, I would put 1.5 times 0 and get plus 12. All right. Or 1.5 times 1 topping, and I would get my cost for my 1 topping pizza. Okay, so that would be what? 13.5. It's going to go up by 1.5 every time. You can fill out the rest of this. 1.5 times 2 and plus 12. 1.5 times 2 is 3. 3 plus 12 will give you 15. Again, it would give you 16.5 and so on. Okay? Now I'm going to finish this table. You're more than welcome to pause and write in and fill in. And fill in that middle process part, okay? But I don't want your video to be like 25 minutes because I'm filling in the process. So now I need a verbal description. So something like the cost of the pizza is $12. Oh, forgot my dollar sign. Plus each additional topping is $1.50, something like that. Okay. Big deal here is your graph. It already has been labeled for you, and you can notice that it goes by 2s on your y-axis. It goes by 1 on your x's. So if I go back to this table, 0 is 12. I'm going to put a dot there. 1 is 13.5, so almost a 14. 2 is 15, so right there in the middle, smack dab. 3, 16.5, so just a little bit above. 4 is 18. And 5, that's the 19.5. And then the last one that we can do is 6. And that will be 21, but that will be like somewhere up here that's off our graph. And, you know, I'm probably way too high anyway. Probably right there in the middle of your O in cost or right below it. Anyway, so we're going to draw a line connecting them. That's much straighter than the last one that I did. Alrighty. So make sure you draw an arrow because it's going to keep going up and up and up. Alrighty, and the last one. So in this one, they give us a table with our x's and our y's already complete. We have to write the equation, the description, and the graph. First thing I'm going to do is my graph. So I'm going to plot these points, 5, 6. So 5, 6. Notice that your graph goes by 3s on your y-axis. 10, 12. And then your x-axis goes by 5s. Makes it a little bit nicer. 15 and 18. 20 and 24. And 25 and 30. Alrighty, so if we notice watermelon and the weights in pounds, the number of watermelon and the number of weights in pound. If we have 0 watermelon, we should have 0 pounds. Doesn't that make sense? We have 0 watermelon, 0 pounds. Okay, and notice that it went kind of up 2 of these and over 1 each time. So that helps us know, too, that we graphed it correctly. Just draw a line through it, hopefully much straighter than mine. Alrighty, there's our graph. Now let's look at how we can write our equation. So I just kind of gave you a hint. How much did it go up and how much did it go over? So I don't know if you can see this much. Let me choose another 2 points. Let's do these. You could do any of these points, guys. Choose 2 of them that intersect nicely. So it's going up 2 boxes, but the 2 boxes really means 6 because 6 to 12 is 6. And then how many is it going over? We said that it's going to go by 5s on your x-axis. So it's going up 6 and over 5 every time. And that is our slope. And we said that it started at 0. So we don't have to worry about a y-intercept. Now over here, if you wanted to put like the decimal for 6 over 5, you're more than welcome to do that. It would be what? 1.2. And you can check my math on that one. Okay, you could definitely type it in. Not type it in. Yeah, 1.2 is probably the easiest instead of writing in 6/5 every single time. But it's going to be 1.2 times 10. 1.2 times 15, and so on. Y'all get the steps? And continue this down. Alrighty, so your verbal description needs to be something about how much does each watermelon weigh. Okay, so I'm going to put each watermelon. That's pretty good. Cursive writing. Each watermelon weighs 1.2 pounds. How many total pounds? Something like this, guys. Okay, or something where you can have that 1.2 for each and every watermelon. Okay, I know my scenario is not 100% done, but you get that each watermelon weighs 1.2 pounds. Okay, and then you multiply it by how many watermelons you have, and you get your total weight. All right, I hope this helps. If you need and ask questions, please get a hold of Miss Hill or myself.